students. Hope you're all doing good. So before we move on to today's class, let us just do a small recap of what we learned in the previous class. So in the previous class, we looked into what is motion and rest, and we saw how things move. And next we moved on to the definition of forces and examples of force. And next we saw the types of force, the contact forces and the non-contact forces, and we saw the examples of contact and non-contact forces. And then we moved into the classification of force. And next we moved on to what happens when we apply force on an object. And then we saw the types of motions, the rotational, circular, linear, oscillatory, curvilinear, and the zigzag motions. And then we saw examples regarding types of motions. So before we move on to today's class, I'll give you an example. Take the case of the hour hand of a clock. In one day, it makes 2 rounds, right? Similarly, look at the bouncing ball. It bounces a certain number of times for a given time interval or period. Similarly, look at the water waves. In a given period, that is a time interval, a fixed number of waves in the shore. So, in all these examples, the motion is repeated in an equal intervals of time. So, do you have any idea about what we are going to learn now? It's about periodic and non-periodic motions. So, what is a periodic motion? When motion is repeated in equal intervals of time, we call it as periodic motion. And when motion is not in uniform interval, we call it as non-periodic motion. So the examples of non-periodic motion is a sagging swing in wind. Here the motion is not in uniform interval. So we call this motion as a non-periodic motion. So next we'll move on to the interesting fact. So, do you notice that all oscillatory motions are periodic but not all periodic or oscillatory? It's because the revolution of the moon around the earth is periodic but not oscillatory. So, what is periodic? When motion is repeated in equal intervals of time, we call it as periodic, right? And what is oscillatory? The to and fro movement of an object is known as oscillatory. So, in the case of the revolution of the moon around the earth, it is periodic but not oscillatory. The children playing in a swing is both periodic and oscillatory. Okay, so the children's playing in a swing is periodic, that is, it's repeated in equal intervals of time. And also it is oscillatory because there is a to and fro motion of the swing. Got it? Next, we'll move on to fast versus slow. So, look at the tall tree. When the wind is gentle, its branches are dancing slowly. But if the gentle wind becomes strong, the branches shake violently. And if the speed increases further, the branch may even break and fall. So, that is, the motion can be slow or fast. Okay, so what is it? A motion can be slow or fast. So now, can we say a motion is slow or fast without comparing anything? When compared to walking, cycling is fast, but a bus is faster than a cycle. Similarly, the aeroplane is much faster than a bus. So, slow or fast is a relative concept, okay, which depends on the motions we are comparing. So, see the example. Can you see? When compared to walking, cycling is fast, right? When compared to cycling, bus is faster. But aeroplane is much faster than all of these. So next we'll move on to what is average speed. So what is average speed? The distance traveled by an object in unit time is called the average speed of the object. That is, if an object traveled a distance d in time t, then its average speed is given by the formula distance traveled by time taken. That is, we denote the distance by d and we denote the time by t. So it is represented as d by t. So what is the SI unit of speed? The SI unit of average speed is meter per second. That is, the SI unit of distance is meter divided by the SI unit of time is seconds. Okay, so we represent the SI unit of average speed as meter per second. I'll repeat. So what is average speed? It is the distance traveled by an object in unit time. So we represent the average speed by distance traveled by time taken, that is t by t. So what is the SI unit of average speed? It is meter per second. Now we look into a problem. A cat traveled 150 meters in 10 seconds. So what is its average speed? Now what is given in the question? The distance traveled. So the distance traveled d is equal to 150 meter and the time taken by the cat is 10 seconds. Okay, what are you supposed to find? The average speed. So the solution is, you are going to write the formula of the average speed. So what is the formula for average speed? It is the distance traveled by time taken, that is d by t. So what is the d value given in the question? It is 150 meters divided by time, that is 10 seconds. So 150 divided by 10 is, we cancel out the zeros and we get 15 meter per second. Okay, the SI unit of distance is meters and the SI unit of time is seconds. So we denote the SI unit of average speed as meter per second. Got it, students? Next, we'll move on to the another formula. Just now we learned that average speed is equal to distance traveled by time taken. So we will denote it as d by t. So now we are going to find the formula for distance traveled, that is d. Okay, so we cross multiply the average speed and time. So the distance traveled is equal to average speed multiplied by time. So average speed is denoted as s and t is denoted as t. Okay, now we move on to a problem. If a ship travels at a speed of 50 km per hour and it sailed for 5 hours, then how much distance it had traveled? So what is given in the question? The speed of the ship, that is 50 km per hour. And then the time taken for it to sail is 5 hours. So what are you supposed to find? It is the distance traveled. So the solution is, you are going to write the formula for distance traveled. D is equal to average speed into time, that is S into T. And then what is the average speed? That is 50 km per hour. So kmph is kilometer per hour, okay, into 5 hours. So when you multiply 50 into 5, you get 250 and per hour and hour gets cancelled, okay. So only we get the kilometer. So what is the distance traveled by the ship? It is 250 kilometer. Got it, students? What is kmph? It is kilometer per hour, okay. So you're going to cancel the per hour and hour in 5 hours, okay. So when you cancel hour and hour, the SI unit for distance traveled is only kilometers. Now we are going to find the time. So you are going to bring the time on the left hand side and you are going to bring the average speed to the right hand side. That is, you are going to bring it to the denominator. Then we'll be getting the formula for time as distance traveled by average speed. So it is denoted by D by S. Okay, so what is the formula for time? It is the distance traveled by average speed. Okay, it is denoted as D by S. Now we look into a problem. Suppose a bus travels at a speed of 50 km per hour and has to cover a distance of 300 km. So how much time will it take? So what is given in the question? The speed of the bus, that is 50 km per hour, and the distance traveled D is equal to 300 km. So what are you supposed to find? The time taken by the bus. So the solution is, write the formula of the time first. So time t is equal to distance traveled by speed, that is d by s. So what is the distance traveled by the bus? It is 300 kilometer divided by the average speed is 50 kilometer per hour. Kilometer in the numerator and kilometer in the denominator gets cancelled and the r goes to the numerator. So when we divide 300 by 50, we get it as 6 hours. Got it? So you're going to divide the distance by speed. So what is the distance? It is 300 kilometer divided by 50 kilometer per hour. So the kilometer gets cancelled. 300 by 50 is, you're going to cancel out the zeros. So 30 by 5 is 6. And the r in the denominator goes to the numerator. So we get the answer as 6 hours. Got it, students? We'll move on to the uniform and non-uniform motion. So what is uniform motion? If an object covers uniform distances in uniform intervals, then the motion of the object is called uniform motion. And what is non-uniform motion? If an object covers uniform distances in non-uniform intervals, then the motion of the object is called as non-uniform motion. We look into what is multiple motion. So what is a multiple motion? When a body possesses more than one simple motion, we call it as multiple motion. Okay. So for example, you are traveling by a train. Okay. Your wrist watch is also sharing the linear motion of the train, but the hands of the watch are also undergoing rotational motion. Can you see? You are traveling in a train, so there is a linear motion of the train, but the hands of the watch is undergoing the rotational motion. Okay, so there are two types of motions, that is linear and rotational. In that case, we call it as a multiple motion. So when a body possesses more than one simple motion, it is called as multiple motion. Next, we'll move on to the science today. So what you're going to learn in science today is about a robot. So the term robot comes from a Czech word robota, which means forced labor. So it's the science and study of robots. So what is the study of robots called? It is robotics. So what are robots generally? Robots are automatic machines. Okay, some robots can perform mechanical and repetitive jobs faster, more accurately than people. That is, some robots can perform mechanical and repetitive. What is the meaning of repetitive? That is a motion that occurs every few seconds. Okay, it happens continuously. So a robot performs a mechanical and a repetitive jobs faster than normal people. Okay, so robots can handle dangerous material and explore distant planets. So what is the study of robots? It is known as robotics. So it is derived from a Czech word which means forced labor. So what are robots? It is an automatic machine. Okay, what are robots? They are automatic machines. They perform the mechanical and repetitive jobs faster than human beings. And it can also handle dangerous material and explore distant planets. So this is the picture of a robot. You have already seen this. Okay. So what can robots do? Robots can sense and respond to their surroundings. Okay. They can handle delicate objects or apply brake force. Example, to perform the eye operations guided by a human surgeon, a robot is used, or for even to assemble our car. Okay, with the use of artificial intelligence, the robots will be able to make decisions for themselves. Got it? With the help of artificial intelligence, the robots will be able to make decisions for themselves, and they perform the eye operations guided by a human surgeon or to assemble a car. Okay, robot sense. So electronic sensors are a robot's eyes and ears. Okay, so what are the robot's eyes and ears? It is the electronic sensor. And for giving the robot a 3D view of the world, twin video cameras are used. and microphones are used to detect the sounds for the robots. And the pressure sensors gives the robot a sense of touch to judge how hard to grip an egg or an heavy luggage. Okay, so what makes a robot the sense of touch? It is the pressure sensors, and the built-in computers are used to send and receive information with radio waves. So what are the robot's eyes and ears? It is the electronic sensors. And what gives the robot a 3D view of the world? It is the twin video cameras. And what makes it to detect the sounds? It is the microphones. And the pressure sensor gives the robot a sense of touch, and built-in camera sends and receives the information with radio waves. So next we'll move on to artificial intelligence. So what is artificial intelligence? It is a branch of computer science that emphasizes the development of intelligent machines thinking and working like humans. Okay. For example, speech recognition, problem solving, learning, planning are all the characteristics of human beings, right? So with the help of artificial intelligence, the human intelligence will be simulated in robots, which makes them to think like humans and mimic their actions. So artificial intelligence attempts to create computer programs that think like human brains. Okay, so these are the pictures of the robots with artificial intelligence. Next, we'll move on to can robots think? Robots can think. They can even play complex games such as chess better than human beings. Robots play complex games such as chess, soccer better than human beings. Okay, so could you see the robots playing football? Okay, so next we'll move on to nano robotics. So what are nano robots? So these are the robots scaled down to microscopic size in order to put them into very small spaces to perform a function. So what are nano robots? Nano robots will be very small in size in order to make them put into small spaces to perform various functions. Okay. Could you see the two pictures of nano robots? And the study of the nano robots is called as nano robotics. Okay. So the future nano robots could be placed in the bloodstream to perform surgical procedures that are too delicate or too difficult to handle for standard surgery. That is, future nanorobots could be placed in the bloodstreams to perform surgical procedures. Okay, and a nanorobot could even target the cancer cells and destroy them without touching healthy cells nearby. So what is the purpose of nanorobots? Is to be placed in the bloodstream to perform surgical procedures, and it can even target the cancer cells and destroy them without touching the healthy cells in our body. Okay, this picture of nanorobot in our bloodstream. Okay, few more pictures of nanorobots. So that's it for today's class, students. Now let us just do a recall of what we learned in today's class. So first we looked into what is the periodic and non-periodic motion. First we saw the periodic motion. Motion repeated in equal intervals of time is known as periodic motion. And we saw the examples of periodic motion such as the wall clock and the waves and the bouncing balls. And non-periodic motion is when motion not repeated in uniform interval, it is known as non-periodic motion. We looked into the example of a sagging swing in wind, And next we moved on to the interesting fact, that is the oscillatory motions are periodic, but not all periodic motions are oscillatory. In that we saw the revolution of the moon around the earth is periodic but not oscillatory, and the children playing in a swing is both periodic and oscillatory. Next we moved on to the fast versus slow. So the motion can be fast or slow. And next we looked into the motion is slow or fast without comparing anything. That is, compared to walking, cycling is fast, but a bus is faster than a cycle, and an aeroplane is much faster than a bus. So a slow or fast is a relative concept, okay? That is, it depends upon motions we are comparing. And we saw these images. And next we moved on to the average speed. So what is an average speed? It is the distance traveled by an object in unit time. So the formula for average speed is distance traveled by time taken, and it is denoted by d by t. And what is the SI unit of average speed? Meter per second. And next we saw a problem on how to find the average speed. Next we moved on to another formula, that is distance is equal to average speed into time, and the average speed is represented as s and time is represented as t. And then we saw a problem related to how to find the distance. Next we moved on to another formula. Time is equal to distance traveled by average speed, that is the distance traveled is represented as t and average speed is represented as s. And we saw a problem related to how to find time. And next we moved on to the uniform and non-uniform motion. So what is a uniform motion? When an object covers uniform distances in uniform intervals, then the motion of the object is called uniform motion. And when an object covers uniform distances in non-uniform intervals, then motion is called as non-uniform motion. Next we moved on to the multiple motion. So when a body possesses more than one simple motion, we call it as multiple motion, and we saw an example related to multiple motion. Then we move on. So the word robot is derived from a Czech word robota, means forced labor, and the study of robots is known as robotics. So what are robots? They are the automatic machines which performs mechanical and repetitive jobs faster than human beings, and it can also handle dangerous material and explore distant plants. And we saw the pictures of robots. And next we moved on to what robots can do. So robots can sense and respond to their surroundings, and they can even handle delicate objects or apply great force. And we saw an example. And next we moved on to how robots sense. Electronic sensors are used for robots' eyes and ears. Twin video cameras gives the robot a 3D view, and microphones detects the sounds, and pressure sensors gives the robot a sense of touch, and built-in computers sense and receives the information. And next we moved on to the artificial intelligence. So what is artificial intelligence? It is the branch of computer science that emphasizes the development of human intelligence in machines. Okay, so we saw examples and pictures of robots with artificial intelligence. So next we moved on to, can robots think? Yes, robots can think, and it can even play complex games such as chess, soccer better than human beings. And we saw pictures of robots playing. And next we moved on to the nanorobotics. The study of nanorobots is known as nanorobotics. And what are nanorobots? They are the robots that are microscopic in size, okay? And we saw the future of nanorobots. That is, it could be placed in bloodstream to perform surgical procedures, and it can even target the cancer cells and destroy them. And we saw the pictures of the nanorobots in the bloodstream. So that's it, students. I have attached the assignments for you. Kindly write it in your notebook. Thank you, students.